Hello and welcome back to the Tin Barn. I'm Pragmatic Lee. As you recall, in my last video I machined this flange washer for the purpose of mounting a grinding wheel on an arbor. Now I got to thinking about after that video that the purpose of this flange is to spread that load out a little bit so that you're not putting all the holding pressure right in the middle. It spreads that out. Well, I got to thinking, need one of these for both sides. And so off camera, I machined the second one for each side of the grinding wheel. Now that grinding wheel, I'm not sure if I mentioned it in the last video, but I'm going to mount it on an electric motor. I've got several electric motors, but every one of them is the low RPM 1725, and I'm hoping it's going to work for this project. But what I'm going to do is take this piece of round stock, 1-inch round stock, and make an arbor so that it will mount on this motor and the wheel can be mounted out here. We'll get in a little closer and I'll show you what we're going to try to do. What I'm starting with is a piece of 1-inch round stock, 3.675 inches long. First thing I think we're going to do is go over to the lathe and bore out this section right here. This will be a 1/2 inch bore, 1.5 inches deep. That is what will slide over the spindle on the motor shaft. Then we'll go over to the mill and drill and tap for a set screw to hold this on. The shaft on the motor back here actually has a flat on it, so we'll only need one set screw. If it was a completely round shaft, we would put 2 set screws at 90 degrees to each other, but this has a flat, so we'll just put in one here. While we're at the mill, we'll move over here right about the bottom of this bore and mill some flats on it so that a 3/4 inch wrench will fit on that to hold the arbor. Now I think I've done a video making one of these in the past, but if I did make a video of that, and I didn't take the time to go back and look, but the one I've got on another motor over here that I've got a buffing wheel on, instead of turning the end down for the wheel to go over in the flange washers and thread it on the end, what I did was make the piece about overall probably an inch, 1.5 inches longer. And again, instead of turning this down, I actually bored out this side as well and put a 1/2 inch bolt, cut the head off of a 1/2 inch bolt and put that in there. But what I want to do today is make this one a little bit nicer, and so we'll go back to the lathe after we get the set screw and the flats milled in. We'll go back to the lathe and turn 1.8 inches of this down to a 1/2 inch, and then thread 1/2-13 for a 1/2 inch in. So let's go over to the lathe now and start with this boring. Okay, I have a 1964 bit. That's just the first one I grabbed over there, and we're going to drill in inch and a, let's see, 1.5 inches. All right, now everything is seated. I'll come right here to the beginning and zero out my DRO. DRO on the tailstock. We want to go in 1.5 inches. Now we'll go with our 31/64 bit. And finally, we'll take our 1/2 inch chucking reamer. All right, now I think we're ready to go over to the mill and put our set screw in and mill our flats. I'm over at the mill now. We're going to locate the center on the y-axis, and on the x-axis we're going to come in about 0.4 inches. All right, so we started out with a spotting drill, then went with a 2-flute spiral tap, and just to be sure that threads went all the way through this, went with a bottoming tap. So now I'm going to put a mill in and get set up to mill some flats. Okay, I've got a 3/8 inch tap, 3/8 inch end mill in there now, which should give clearance for the thickness of the wrench. Let's touch off. We're going to go down about 125 thousandths on each side. All right, obviously what I did when I put this piece in the 1-inch collet, 5/6 collet in the square block, and I lined that block up right with the edge of the mill vise jaws. All right, let's try a wrench. Good fit. I'm going to deburr this. We'll go back over to the lathe and mill off our stud for the wheel to go over, wheel and flange washers, and thread the end for the nut. Back over at the lathe now with our workpiece turned around and good and tight in the chuck. What we're going to do for a distance of 1.8 inches, we're going to turn this down to a 1/2 inch. So what I'll do is make a pass, then measure take a measurement, set the DRO up to zero out at a ½ inch, and then as we get a little closer to the end, I'll double check those measurements. By the way, I've got my work stop set. It's behind the carriage now, so you can't see it. But I've got my work stop set up to bottom out. It shows 67. The DRO says 66. So I'm going to leave about 2/1000 there, that if I need to clean up with the file, I can. All right, I need to get that extra 2/1000 there. That's exactly what I was looking for. What I want to do now is take my marker and I just want to be sure that I thread to just inside where that marker is. So I'll get set up for the threading. I think I've probably said it on the channel before, but ½ inch threads, 12, 13 millimeter, are about my switchover point between threading with a die versus single point threading. If I had multiples of these to do, I would probably set up the change gears on here. And this lathe does not have a gearbox. You have to change the gears. But if I had multiples to do, I would set up to do single point threading. But with just this one, I'm going to use a die. And these dies are designed with a starting side and a finishing side. So I'll put the starting side up here. And let's see, I need to back up just a little bit so I can line up straight. All right, I've got my tailstock locked in position and got the jaws of the chuck flush here, or at least inside. And I'll use this flat edge on the chuck to guide the die in. So that's got it lined up. Now I'm going to turn my RPM way down and get my anchor lube again. I like to use the anchor lube threading no matter what the material is, whether it be aluminum or steel. All right, let's still just a little bit fast there. But that got us a good thread. But now what I want to do is turn the die around and put the finished side up and cut our final threads. And I think this time, instead of trying to power tap it, I'm going to bring it up and simply use my adjustable wrench and do a two-hand operation. With one, I'm turning the chuck, the other, I'm keeping the tailstock tied up against it. All right, I'm going to get this off. Then we'll mock it up one more time while it's still on the lathe. All right, I think that's going to work fine. Let's go back to the workbench, put it on the motor, and do a quick little recap. Back at the workbench now, this is the motor that I'm going to use to set it up with. Now, upcoming project, probably the next video, I'm just not sure, but I'll go through in detail what I'm going to be using this for. You've probably seen this sitting here on the workbench in this video and the one before, but this is going to be a drill sharpening station. I'll explain in detail in the next video why I chose to go with a dedicated motor and wheel versus just using this with my standard bench grinder. But we'll get to that in the next video. Now in the Arbor, I put a 1/4 set screw in. We'll tighten that down, let it find that flat. One of our flange washers, the wheel, our other flange washer, and then our nut. Using those flats we milled in the Arbor to hold it. And you see what we're getting leading up towards. All right, let's turn it up. I think it's running pretty good. There's just a little bit of vibration there. This being a non-dressed wheel, it's probably not perfectly round, but for a drill bit sharpening station, I think that's going to work great. Hope you folks enjoyed making this Arbor. Again, it's another simple little project, but like I say, I hope you enjoyed it, and come back for the next video and see it being put to use.